So this is how we name aldehydes in organic chemistry. And if you don't know how to name your alkanes, you should go back and watch that video, because it's going to make this video so much easier, because it's kind of the easiest way to name aldehydes. So aldehydes are a carbonyl type functional group. As you see here, we have a carbon double bonded to an oxygen, bonded to a carbon on one side and a hydrogen on the other. That's our aldehyde. Now there is a simpler form of aldehyde known as formaldehyde, and it looks like this. It's a carbonyl, it's terrible carbonyl, I'm sorry, oh well, with an hydrogen on either side. That is formaldehyde. Okay, it's the simplest aldehyde. And then there's what's known as acetaldehyde, which is one carbon, one proton. Okay, that's acetaldehyde. Those are kind of common name ones. Anyway, let's get into it for our IUPAC naming. So the easiest way to name an aldehyde is to first figure out what its alkane name would be if we didn't have this carbonyl here. Then you lop off the E and swap it out for an AL at the end. So let's count this. We have what? 1, 2, 3, 4, 5, 6 carbons. So we know to name an alkane, the prefix is the number of carbons. So for 6, the prefix is hex. And we know for an alkane, the suffix is ane. So if this was an alkane, which it's not, it's an aldehyde, it would be hexane. Now we have to lop off this E here. So we have hexan, and then Al. So hexanal, not hexanol, hexanal. This hexanol is an alcohol. Now, usually we have to put a locant or position labeling when we have functional groups like this. However, because an aldehyde by definition has to be at the end, we do not put a locant number on it. And if it's just an aldehyde, or if there's other groups that are lower in priority than our aldehyde, the aldehyde is by definition our one position. So we actually, say we had a methyl right here. We actually wouldn't count this way, we would count this way, with this being the one position. And so it'd be what, 1, 2, 3, 4. So it would be 4-methyl hexanal. That's what that would be. Now, there are groups that take higher priority than our aldehyde, such as carboxylic acids. When you are naming the aldehyde as a substituent, sometimes you'll see it called a carbaldehyde. It's usually for carbaldehydes on rings I see. Carbaldehyde like that. Like benzaldehyde could also, sometimes you see it called benzene carbaldehyde. Also, if it is a functional group, say we have, let's go with benzoic acid. So we have benzoic acid here. As you can tell, I'm not an artist. We have benzoic acid. Say we have our aldehyde over here. The carboxylic acid takes precedence over our aldehyde, meaning that is this is the highest naming priority. So it's going to be named as benzaldehyde. But we still have this, I'm not sorry, not benzaldehyde, benzoic acid. But we still have this aldehyde over here, so we're naming it as a substituent. So the name for this would be benzoic acid. And this is our substituent, and then it could be carbaldehyde. In this stage, in this way, we're probably not going to say carbaldehyde, we're going to say what's formyl. So like this, form, YL, and then number of positions of 1, 2, 3. So 3-formyl benzoic acid. Carbaldehyde is usually used when it's on some sort of like ring. So think of like a cyclohexane ring, like this, like that. That might be called cyclohexene carbaldehyde. I personally wouldn't call it that, just because I'd probably go with the formula. It's just what I like to use, but you can call this carbaldehyde is a mouthful. Am I going to run out of room on the screen? Is that even on the screen? Oh, it is. So there we go. So just a quick recap, when we're naming our aldehydes, because aldehyde is carbonyl group, C double bond to an O, carbon on one side, protein on the other. We take the alkane name, so it's 1, 2, 3, 4, so it would be butane. A little more of you. We're going to lop off this E, AL, so that's butanal. If you want more organic chemistry videos, be sure to hit that follow button. Check out the other videos. There's tons of other naming videos on here.